Good afternoon, everybody. I'm very, very excited to be here with you all this afternoon. In a normal kind of year, we would have all been kind of getting together and meeting in person. But with this strange year, we have started to embrace new technologies, be able to embrace different tools for being able to get together remotely. And it is such a blessing to be able to sit down in front of my computer and spend a little bit of time with you guys today to talk a little bit about Pulsar and where Pulsar is going. But one of the things I really started thinking about with this conversation was this aspect of the world we live in today. It's a different world, and isn't it amazing how every one of us has a webcam? We have microphones built into our computers, and we have these amazing tools that are right at our fingertips that we kind of took for granted, right? We used them on occasion. We used them for getting together to do a remote meeting here or there. But now that tool is becoming an essential part of our everyday lives. The aspects of cameras and microphones and being able to communicate remotely has now become fundamental to how we do business. What's interesting to me is that aspect of how what we had right in front of us was more than sufficient to do the things we need, right? The camera that I have on my MacBook sitting in front of me and the microphone that I have built into my computer, it does the job. It does what I need it to do. But my background is one in things like television production and communications and theater, as well as computer science. And that essential tool that was in front of me, while functional, didn't really give me the quality that I wanted. It didn't give me the ability to do the things I wanted to do with it. It didn't allow for me to do some of the more higher quality types of interactions that I wanted to have. Camera quality is good, but it's not great. My microphone quality is good, but it's not great. And that's kind of at the center of what I'm talking about today. And to showcase that, I needed to make a change. While I have tools that are very functional sitting in front of me, I needed to do something a little different to provide a little bit better experience, a little bit more functionality to what I was hoping to accomplish when I would create presentations and sit down and talk to people like you guys. And so I needed to make a change. It wasn't necessarily a big change. It was more of an upgrade, a change to how I operated and a change to what I had in front of me, leveraging similar capabilities, but doing so in a much more efficient and a much better quality way. And so let's take a look at what that looks like now.
There, that's a little bit better. With just the improvement of a different camera, some better lighting, changing my background a little bit, and more importantly, upgrading my audio setup so that you can hear and understand me better, things are a lot better for what I'm trying to do. You see, that's what we're here to talk about today, is this aspect of how we can sometimes fall into this rut of using a tool that's available to us because it's there, not necessarily because it's the right tool for the job. We have so many cases in technology where we look at these types of applications and we use tools that are available to us because they're there. When I was starting this whole process of doing more online presentations and interacting with people over the web more often, I first looked at my webcam and my microphone and thought that it was doing the job just fine. For the 20% of the times that I had meetings online, my webcam and my laptop worked great before COVID. But now that I'm doing it almost every day, and more importantly, having multiple meetings every single day, I needed a setup that allowed for more flexibility. I needed to be able to change my setup to meet my new demands and meet the new requirements that I had for all of the interactions that I was having online. Conferences became virtual, which meant I was doing more recording of information so that more people could listen and understand what we were talking about. So I needed to change how I was approaching building a a solution to solve my problem. And that's where I looked at my web camera and my audio setup for my laptop and said, while it works, while it's functional, it doesn't fully meet the requirements that I have for doing my job. And so I needed to make an improvement. And that improvement wasn't a big change. I still have a web camera. I still have a microphone. I still have lots of things that are available to me to allow me to do my job. But the reality is that what I have now is a better solution. What I have now allows for me to do my job better. And that's really what I wanted to talk to you about today, is that in our technology-driven world, we tend to fall into that rut of trying to fit a square peg into a round hole. You know, that's what really reminded me of this childhood toy that I had. It was a square cube that had multiple shapes cut out onto it in different sides. And as a child, it taught me that there are certain circumstances that you can't put a square peg into a round hole. From a very early age, we had these toys that were trying to teach us that sometimes you have to think through what is the right approach to solving a problem. If you want that square peg to be inside the box, you had to find the square hole to put it into. And if you didn't, and you tried to force it through a different hole, you ultimately broke your toy. And I think that's where we've started to get with some of the technologies that we have available to us in our technology-driven world. We have so many solutions that are available to us that allow us to do the same type of operation, but call it by a different name. Today I want to talk a little bit about what is messaging, and how is messaging at the core of all of these different pieces that we now have with regards to stream processing, event-driven architectures, and building microservices. It all centers around one fundamental concept, and that's communication. But before we get into that, let's do a little bit of an introduction. My name's Bill McLane, and I'm actually the messaging evangelist at TIBCO Software. So I've been dealing with this concept of data distribution and communications for well over 20 years. What's really interesting to me is that a lot of the things that we talk about today with regards to streaming and event-driven architectures and microservices, like I said earlier, all kind of fundamentally go back to its roots in messaging. So we really need to take a look at what is this concept of messaging? Why is it there, and where did it come from? You know, and what's interesting to me is that messaging really at its foundation, when it was developed, not just 20 years ago, but 40, 50 years ago, it was built and designed to provide a framework for exchanging data within an ecosystem. It was built and designed to allow for applications to normalize how they communicated with each other so that they had a seamless approach to providing data exchange across an ecosystem. You know, there's software components and hardware components that have provided to do this communications. And it's really interesting to see how necessary that became for different applications, whether it was to provide integration between disparate applications. You know, long ago we had these silos of application development, and we needed to get information that was stored in one area to another. And how did we do that? We did that with messaging. We needed the ability to scale that communication. So originally, when we started this process of communications 45, 50 years ago with technology, it was a one-to-one type of relationship. And we needed an approach that allowed for a one-to-many approach or a many-to-many approach. And now we have the introduction of things like IoT, where the devices go from tens of thousands to hundreds of thousands, if not millions of devices that need to be allowed to communicate their information in a seamless fashion. The challenge is that communication has never been easy. You know, if we just look at how differences in culture that we have today, we clearly can see that communications is not an easy thing to accomplish. One person's approach might be looked at differently from another person's perspective. And that's really what messaging is trying to do in the technology world, is to provide that normalization of data distribution. Now, it all started back long ago. This concept of messaging is not new. I'd like to say that, when I started 20 plus years ago, that this was a new concept, but even then it wasn't a new concept. This concept of providing a contextualized approach to sending and receiving information has been around well before the computer technology industry. We've used these concepts for data distribution well before we had the technology to leverage it. It's just that we've adapted that technology to be more appropriate for how we use it within application development and software development today. These components for sending and receiving data, they're not new in design, right? We've built them to scale, we've built them to grow, but they're all built on the concepts that were started, many, many years ago, whether it's looking at ARPANET and how it used a logical map of data within a network to provide a communications framework. That's all manifested itself up into these concepts that we have today with regards to messaging, streaming, event-driven architectures, distributed logging. They all are built on the same foundation that focus on a normalized framework for communications in an ecosystem. But the real question comes down to is why would we use messaging? Why would we want to use messaging as a technology for data distribution? Especially if we all speak the same language, right? We all have this aspect of, in the computer world, we can all speak the same language. We all can have and decide that we could all communicate on the same path. But the reality is that never works, right? Just like today, I'm speaking to all of you in English. I can tell you outright that almost all of your English is far better than my Mandarin. And so if I tried to speak to you in Mandarin, we would never have a cohesive conversation. But that's why we choose to use a single language. But wouldn't it be great if I could speak to you in English and you could hear me in the native language that you're accustomed to? Wouldn't it be great if we could transform all of the information that we're sending and receiving and allow for it to be interpreted and represented in the most logical way possible for a given application? And that's really what messaging does. It allows for this normalization of context. It allows for us to send and receive data and translate it so that applications can use it appropriately without having to make sacrifices on what that data is. When we're communicating one-to-one, that becomes a fairly easy task, but when we start looking at making that communication more widely available, for example, if we look at the difference between you and I speaking together in a room versus me speaking to you the way we used to do these types of conferences in a wide open arena, there's so much that needs to be taken into consideration. One-on-one, I don't have to worry if you can hear me because I can get closer. But when there's a large room, I have to worry about what are the acoustics of the organization that we're using? What are the sound equipment that's available? Do I have microphones? How do I project? Can everybody understand me? Can everybody see me? Is everybody getting the same message that I'm trying to portray? And the reality is that when you start to look at all of those different variables, context becomes extremely important. And that's where messaging plays a key role, is it allows for our systems to communicate and normalizes that communication, provides context so that software-developed applications and hardware-developed applications can use that communications efficiently and leverage it to make decisions on what they're going to do next. With messaging, we have the ability to see, did everybody get the message? Is everybody understanding the message? Is everybody available to hear the message? All of these concepts are built into this communications framework that we call messaging. So that's really what messaging is all about. It's the ability to connect anything, anywhere, anytime, and use that information to develop applications with different patterns. Whether or not I speak the same language, whether or not I'm building a Java application or a Python script, I may want the ability to use the data that I have available in either one of those applications seamlessly so that I can open my world to seeing what's available and leverage that data appropriately across applications. Or whether it's from mobile devices, sensors,
or back-end systems. All of that information can be relative and contextual in my decision-making process. So when I look at stream processing or building an event-driven architecture, that information becomes vitally important. And how I communicate that information becomes extremely relevant to my architecture and design. So let's go back and look at our toy. Let's go back and understand how many pegs and how many holes do we have to fill. You see, that's where this challenge in messaging and data distribution really comes into play in today's world. Back 40, 50 years ago, we had a few number of solutions to solving a large, vast variety of problems. But today, we have a vast amount of solutions and a vast amount of challenges that we need to solve. So how do we pick the right peg for the right hole? Don't you wish it was as simple as our toy, where we could just look at it and know that for this type of application, we need the square peg to go into the square hole? But unfortunately, it's not that easy. And unfortunately, with technology, a broken toy typically has a lot more impact than a sad child. It could mean millions of dollars of loss. It could mean whole supply chains getting shut down. It could mean life or death in many cases. So when we look at how do we leverage the right tool for the job, we really need to take a very concise approach to understanding what are we trying to solve and what's the best solution, and more importantly, how do I migrate that solution to continue to grow with the application development that I'm doing. So let's look at this messaging concept a little bit more, especially with all of the options that we have available to us today. How do we choose the right communications vehicle for the applications that we're building, right? There's so many choices out there. If we just look at different terminology that we have in the messaging ecosystem, we have concepts of messaging, distributed logging, event-driven architectures, streaming. What do they all mean and how are they different? And if we want to go even lower, we can talk about things like protocols like AMQP, MQTT, DDS, all of these different protocols that are built and designed to allow for seamless communications. Isn't that what JMS was originally designed for? The Java messaging system was supposed to be the nirvana for providing a framework for communications. But it really didn't define a protocol, it defined an API, which meant that everybody's implementation was different, which meant we still had to provide translation between different JMS providers. That's really the challenge, is that we have all of these different options. If we just look at open source, we've got Eclipse Mosquito for MQTT, Apache Kafka, Apache Pulsar, we've got Apache Artemis or ActiveMQ, RabbitMQ. What's the right tool for the job? You know, that's really where I think we have to look at what are the requirements. With so many options we now have, we really need to look at how do we build a solution that allows for us to choose the right tool or the right peg for the right hole. What are the requirements, right? Or what will the requirements be? Are we talking about real-time data distribution? Are we talking high throughput? And what does high throughput mean to you? Is it low latency? And again, what is low latency? Is it transactional? Is persistence required? Is it single site, multi-site, cloud? What are the acknowledgements? All of these things have a role in what peg we're going to pick for the right hole. So we really need to look at that approach of what are the requirements. But more specifically, we have to look at the approach of what is the application, right? I mentioned cloud. Are we looking at a solution that's going to span both on-premise and cloud? Is it a fully cloud-native solution? Are we building something to provide integration services, stream processing? Are we building a foundation of communications for data analytics? Or more importantly, building microservices or IoT infrastructure to provide sensor information to be processed and sent to multiple different locations? That's really the key to understanding what we're building, right? So when we go back to those options, we need to look at a framework that allows for us to pick the right solution for the job. And the biggest challenge is we also need to be able to pick the wrong tool, right? Being able to have this crystal ball that we can look into and see all of the different requirements that we have and know where we're going to be going in the future doesn't exist. What we really need is an approach and an architecture that allows us to choose the right tool for the job now, but ultimately allows for us to grow and migrate beyond that tool and continue to leverage the skills and the tools that we have, but potentially expand it to other opportunities that we have within our enterprise. Picking a solutions for communications that's built on low latency may be very applicable and relevant for a market data trading application. But the same low latency aspects might not have the same relevance if I'm trying to do transactional processing or 100% guaranteed data delivery across a multi-zone cloud environment. They have different applications, they have different requirements. And so how do we merge this concept of choosing the right peg for the right hole and allowing for us to build the cube that has all the pegs and the holes available to us to select and play with as part of our toy? I think the key in all of this is that aspect of we need to recognize and accept that one size doesn't fit all. That there is not one solution that meets every single requirement, every single application, and every single approach that we have to build and architect. I think that we've tried so hard to find this nirvana and say that this one tool is the best for everything out there, and we've forgotten that when we do that, what we get is a tool that doesn't really meet any one demand really, really well. So I think we need to really look again at our toy that we've played with since we were kids and look at the approach of fitting the right pegs into the right holes and building an architecture that allows for us to make choice based on our requirements and seamlessly integrate those choices together so that we have a framework for communication that allows for us to interoperate, intercommunicate, and do so without sacrificing individual components because we have a tool that already exists in front of us. Just like with my video and audio setup, while what I had worked, it just wasn't working to the level that I needed it to. So augmenting certain aspects of my setup made a lot of sense. Does that mean I never use my web camera because I have something better? No, because there's many times where just using my web camera is far more efficient and quicker than setting up a system that is designed to provide me with better visual and audios for things like conferences and large-scale teleconferences. So I think that's really the key. And that's what's interesting when we start looking at this whole debate that has been going on in the open source community around Apache Pulsar versus Kafka. You know, I think that we have a lot of benefits with both of the solutions that are available. You know, Kafka is really what I would argue, the big player in the park, right? They've been around. It's highly leveraged, and it really was what I would classify as one of the really truly open source solutions that was fully capable of meeting a large number of these enterprise communications requirements. It's built for pub/sub messaging and streaming of data. It's designed around distribution of real-time data logging. And because of that, it can really solve a lot of the problems that many applications were trying to solve with regards to reliable data exchange. But again, where it was built from and what it was built for means that if I try to shoehorn it into a different category, it's not really ideally suited for certain aspects of those applications. It's great for a single data center, but when I have to expand to a multi-data center approach or a global geo-located type of operational model, Kafka's not built for doing that. And so to leverage that type of functionality, I need to look at other components and bring in third-party solutions to do things like replication with MirrorMaker, and it makes the solution far more complex. Can it work? Absolutely. But is it the right approach to solving my architectural need? That's where Pulsar comes in, where it really took a different approach. It took the approach of enterprise communication first, and how do I leverage a large-scale, geolocated, multi-tenant type of environment, and do so in the same way to leverage those technologies and use those technologies to meet the same similar types of requirements around stream processing and data distribution. Those are the things that Pulsar has been built for. So I don't think the debate between Kafka and Pulsar is one better than the other. I think we have to look at this as an approach that says that each of these solutions is built and designed for specific strengths and weaknesses. Kafka's built around a flexible architecture and design. It was built for high volume data and data resiliency. And it was designed to provide long-term data retention. So it's great for things like replay of services, where I want to store data for long periods of time and use that data days or weeks later. But it doesn't have the features and functions for things like multi-tenancy and geolocation. And one of the things it's built for is to build a lot of the operational functionality into the application. Kafka applications can do a lot of things, but they have to build them themselves. Where Pulsar was built from a different approach. Its brokers are designed to provide you with that flexibility of an enterprise type of deployment into multiple data centers or multiple geographic zones. It's got multi-tenancy and resource management natively built into it, and allows you to leverage that more appropriately for a large-scale multi-tenant type of environment. And it's designed for high scalability and providing more functionality in the brokers versus into the applications. So it's really two different approaches to solving some similar problems. And that's where the debate, I think, is really, somewhat irrelevant, especially now that we have the opportunity to leverage Kafka and Pulsar. We have the ability to use KOP as a solution to existing Kafka-based architectures and to take them to the next level. So if you have Kafka today that's being leveraged within a single data center or being leveraged for streaming analytics on a small scale, and you need to expand that to a large scale, you can use Pulsar as a native solution to supporting Kafka and the protocols that Kafka supports, so that applications don't have to change, but you can gain the benefits of all of the features and functions that Pulsar provides with regards to enterprise architecture. That's really where I think this Kafka and Pulsar is going to be the next generation. It allows for us to use the appropriate tools for the specific application needs that we have, but does so in a way that allows us to put the right pieces together. So with Kafka and Pulsar, I can now stand up Pulsar brokers that not only speak Pulsar protocols, but also speak Kafka protocols. So my applications can communicate directly using Kafka client libraries and interface directly with Pulsar brokers using the Kafka protocol handler and leverage the Pulsar topics just like they would in a Pulsar environment or a Kafka environment seamlessly. And by doing that, I now have the ability to unlock all of this potential for geo-replication and multi-tenancy and Pulsar functions that I didn't have available to me in Kafka. So without sacrificing any of the features and functions that I've built using my Kafka ecosystem, I now have the approach to be able to leverage that tool and grow it beyond its existing deployment, beyond what I originally intended it to do, and grow it far beyond the demands that I might have originally thought. So instead of having to have that crystal ball where I look and see all of the different possibilities, I now have a toolkit that lets me plug and play the right tools together and bring these components together. And not only is it Kafka, but it's also things like AMQP or MQTT. Being able to leverage the approach that one size doesn't fit all, that we should use the right tools, pick the right pegs to go into the right holes to allow us to use the right systems and have our application developers make the right choices based on their requirements. And then on the infrastructure side, bring those all together in a seamless integration that allows for a single solution for data distribution and communications. Whether it's event-driven architectures, stream processing, microservices, IoT, all of these things have the same challenge, which is they need to communicate, and they need to do so without sacrifices. That's really why we at TIBCO took on this approach of providing a single solution for data distribution called TIBCO Messaging, which encapsulates some of our proprietary offerings with things like TIBCO EMS for JMS connectivity, TIBCO FTL for extreme low latency and high performance, high volume, multi-million messages a second type of distribution, and coupling that with open source solutions like Eclipse Mosquito, Apache Kafka, and Apache Pulsar as a solution to providing data distribution that provides seamless integration. Being able to tie all of these things together and use them without sacrifice, without compromise, and allow for the seamless integration between them so that as my demands changed, I can move from one solution to another with minimal impact to my application development. And that's really where Kafka and Pulsar becomes a huge benefit to our ability to use the right technology for the job. I can use Kafka and Pulsar to have purpose-built applications that have already been deployed on Pulsar and use them in a Pulsar environment, but I also have the ability to leverage all of my ecosystem of Kafka and leverage the Kafka applications to feed data into Pulsar and to many of the other solutions like MQTT, AMQP, and many others. That's really where we at TIBCO felt that Pulsar provided so much value, is that it allows for us to extend these mission critical types of applications that are being deployed into things for stream processing, event-driven architectures, or data analytics, and allow for our customers to unlock data in multiple different ways without sacrificing what they've built with their existing solutions and providing them with access to so much more open source technology and being able to use that appropriately, putting the right peg into the right hole. So with that, I'd really like to thank everybody for their time. It has been truly a privilege for me to be able to communicate with you. I'd love to be standing in front of all of you and be able to sit down and talk about how you're using Pulsar and Kafka in your environments today. But, unfortunately, we don't have that luxury currently. But we do have the ability to communicate, and that's really what it's all about, is the ability to provide the seamless communications. So with that, I'd like to open it up to some discussion about questions and answers that you might have around either TIBCO Messaging or Pulsar or Kafka and Pulsar. Any of those questions that you have, I'd be happy to answer for you now. It's a little bit late my time, but I'm here to discuss those with you. And not only that, I'd like to direct you, if you have any questions about just messaging or stream processing or data distribution or data analytics, please check out TIBCO. We are one of the largest integration services, data analytics companies in the world, but our name is not really widely known. We power so many things that you encounter in your everyday life, and you just don't know it because we are, one of those behind the scenes types of companies that we power the world you live in. And so if you want to get more information, you can go to tibco.com. I've provided a link here for you to see our messaging page, but there's also so much more with regards to integration, cloud integration, event processing, data analytics. We have it all. And so if you have any questions, please feel free. We're going to open it up for some questions now.